All right. Welcome back for a second and final session, the part 2 of the CCSP mentorship program. We are happy to co-host this program with IC Squared Hyderabad chapter and IC Squared Colombo chapter. And I'm sure that you would also benefit out of today's session because we're going to discuss the remaining parts of the total program on cloud security. So I also want to take this moment to thank the IC Squared Hyderabad chapter leadership team, and especially on Rug for you for taking time to put the content together and deliver it for our prospective members and our existing members and who have an interest in cloud security. I also want to take this moment to thank our industry partners, FITIS and SLASCOM. I also want to mention that IC Squared Chennai chapter has shown interest to join the program. So I am hoping that members of the Chennai chapter or people affiliated to the Chennai chapter would also be joining this program. So with that note, I would hand this session over to Anurag. Anurag, over to you.
All right. Thank you, Sujit. Thank you, everyone, for joining again. I hope the last session who attended benefited in terms of understanding what the CCSP is all about. And also we went through the two domains. So this was the schedule last time. On May 13th, we covered domain 1 and domain 2. We did questions, and we also, before that, went through the overview of CCSP as a certification, what it has, and how to approach it, shared some tips and tricks about it as well from my experience, what worked for me. Today, it's going to be a bit too much, honestly, because there's a lot to cover in a very limited time. So we will try and make it as effective as possible. So we will be covering essentially 4 domains, so domain 3, 4, 5, and 6. Those are pretty long and deep domains as such, but we'll try and stick to the timeline. And as I said earlier, we are not intending to kind of go through the course end to end. This is not a boot camp, so it's only to give you all an idea of what that domain includes, give you a feel for it, a flair about it, maybe do some questions, and then as a result of it, you would get an idea what to expect as you get into that domain while you study for CCSP in a formal way. So we will take, from a schedule standpoint, we will have about an hour from now. We will try and cover both domain 3 and domain 4. We will have questions done. So as you can imagine, that's a lot. So we will keep it a bit, as you say, a mile wide and an inch deep. And then also we'll break at about 2 o'clock for 15 minutes. And then we come back, we again continue for about an hour before we break again at 3:15. So that would be those would be the 2 breaks so that we get a chance to again, refresh ourselves while we are in this session. So with that, I'll jump straight into it. So domain 3 really is about cloud platform and infrastructure security. This is where it starts getting a bit technical in this domain. Domain 3, it talks about all the infrastructure, which includes the physical components, such as the services they provide in the communication infrastructure that connects with the cloud. Each component has its own security requirements and shared responsibilities. Eventually, we can also talk about how the cloud supports the business continuity and disaster recovery to an organization, because with the capacity or the capability of cloud, the traditional ways of trying to achieve BCDR is significantly reduced from a cost standpoint, and also how BCDR, our cloud can be used as a tool, as an alternate while you implement your BCDR strategy. So we'll talk a little bit about it. Let's move. That's essentially the overview of the domain 3. Now, these are all the cloud infrastructure companies that you see here are all physically located within the cloud service provider. The physical environment is primarily the sole control or within the sole control of the cloud service provider. Physical environment typically includes all about the log security, physical personal security, lights, fences, etc., and all those stuff. Then we move to the next layer, which is the networking component, again, which is hosted at the cloud service provider, is the responsibility of the cloud service provider. Public internet, in terms of the medium that connects to the cloud, is a shared responsibility. Here, the cloud service providers should support the secure networking protocols, while the customer's responsibility is to make sure they use and implement those protocols like TLS, or SSL, HTTPS, so on and so forth. The next layers, again, when we talk about compute, primarily under the control of the cloud service provider, these are the infrastructure that delivers the virtual machines, the disk processor, memory, etc. More or less, the challenges are same as that on-prem. The only thing that gets unique in cloud scenario is the multi-tenancy. So the cloud service provider is responsible to ensure that the controls that they implement within their environment ensures that the multi-tenant architecture is working securely. And that's what makes it very different from a traditional architecture. Again, so storage, the cloud service provider is again responsible for the physical protection, and the customer is then responsible for the security and privacy of the data that resides within the storage environment. So as you see, I think as you move from network layer and above, the shared responsibility concept starts coming in more and more, depending on which service model you're using, whether it's infrastructure as a service, platform, or software as a service. Shared service responsibilities may change, but as I said in the previous one, also at all times, the physical environment is in the control of the cloud service provider, and on the other end, at all times, the data is the sole responsibility of the customer. In between all of that, all the layers, the shared responsibility model will shift this way or that way, depending whether you're using infrastructure, platform, or software as a service. So in the interest of time, I'll move on. I just wanted to give you a sense of what the different the components are. I covered these. I'll probably move on from this concept of virtualization. There is one thing that this talks about is type 1 and type 2 hypervisor. So in the context of virtualization, this is important to know because in a cloud scenario, you'll typically have a type 1 hypervisor, which the cloud service providers use. The difference really is in a type 1 hypervisor, so there is no host OS. The hypervisor is embedded into the hardware that the service provider uses. So there is no traditional virtualization model where you see on the type 2 side, on the right side, where you have the hardware on which you run a host operating system, on top of which you run a hypervisor, which then allows you to create virtual machines having guest operating systems. That's a type 2 hypervisor. This is what we typically use on a personal capacity. If you're running a Linux VM on a Windows operating system, that's what you use, on your laptops probably. That's the type 2 concept. Type 1 is what is more commercially used in the cloud service provider end. Type 1 is much more faster because you have less number of layers to go through when the system interacts. And type 1 is also more secure compared to type 2 because you don't have the host OS in between, which will then expose you to many more vulnerabilities that may be exploited and then puts your hypervisor at risk for all the tenants, for example. So it's more secure because you have less components involved. It's much faster, and probably that's the reason why it's much more popular in a cloud service provider context. I think we will move on. I think as you could go through and you're looking at the slides, you'll see that there's a lot that this domain covers. There is a lot of, it basically, all the layers that we saw in the initial slide, starting from your physical environment, network and communication, compute, storage, virtualization, management plane, it essentially covers each of those components in detail. It talks about what are the what are the unique challenges that the cloud poses, because traditional challenges of running those components remain the same, plus there are unique ones. And then it also talks about the controls or areas that you would probably have to consider to make things secure and resilient. One of the things that you would always see as you go through this or many other domains is, if you remember the characteristics of the cloud in the beginning when we spoke last time, which was in the domain 1, the characteristics of the cloud are also the source that makes cloud unique from a risk standpoint. Multi-tenancy, for example, is one such thing. Self-service is, for example, the other such thing, because self-service allows you to move users to create VMs and host data just by a click of a button or with a credit card that they have, which creates a risk of a less management control than you would have otherwise. Broad network access, the another characteristics, is also the source for many risks, because just like you have access to the cloud resource, anybody else with internet has access to cloud resource. So again, the prominent controls there again becomes secure transmission, use of encryption, authentication, so on and so forth. So I will not be going through all of this so much because we won't have a lot of time to cover the other things. I will actually keep moving. But if there are any questions, do let me know. I just wanted to introduce what this domain 3 is about. It again goes back to what I just said. Understand what infrastructure components really are, which is from the physical layer all the way to the management plane or the management console from where you actually administer things. Plus, consider all the cloud characteristics that will come into play, and then think about the risks that it will expose the cloud environment to, and then eventually think about the controls that you would want to do. In the cloud environment, the strongest control, there are probably two things that will resonate everywhere. One is encryption, because you just don't know where your data may be or who has access to it accidentally. So encryption is one of the most prominent controls you will hear everywhere to protect your data. And the second thing is authentication and authorization, or the use of IAM with multi-factor authentication, etc., to make sure that you control who has access to data as well. I think the rest of the controls, it primarily would be more or less similar to what you would experience or employ on a traditional environment as well. So I do have a knowledge check now. So if you are able to log into to this through this QR, we can then do a bit of questions, which is about this domain, and we'll see if there are any questions as well. Let me see if I can move there. So you should have it now. It should be coming up on your screen. The first question: your organization has its prod environment in a cloud environment. You're considering using cloud services, cloud backup services for your BCDR purposes as well. What would probably be the best strategy in terms of redundancy and resiliency? So hope you will be able to answer this. Let's see if you're able to answer this. Are you able to see it and answer? Yeah. Okay, so I will lock the answer now. And I'm not sure if you are able to see the screen properly. Let me just see. Just give me a minute. I'll be able to. Just give me a minute. I was just trying to share my screen separately.
So hi all. I mean, while Anurag sorts out the technical glitch, please, feel free to engage with him, right? It should not be just a monologue where he's alone talking. I know you're participating in all the questions, surveys, and things like that, but feel free to post questions, engage with him, discuss, so that the sessions will be much more fruitful. Okay, guys?
Okay. Let me know if now you can see. I think this would be better. All right. So thanks, Sujit, for that. I really appreciate if there are any questions or any inputs that you have from your experience to add. So on this question, the C, use another cloud backup provider, another cloud provider for your backup, because you cannot put all your eggs in one basket, right? So that's essentially where it comes from. And I think most of you answered it right, which is correct. Let's move to the next one. So you are in charge of creating the business continuity and DR plan and procedures for your organization. You decide to have a tabletop test of the BCDR activity. Which of the following will offer the best value during the test? And those who are on this particular site can answer this question. I hope you can see it on your screen now as well. Yeah. Any responses on it? So I'm not seeing any response. Any thoughts on this one? When you're doing a tabletop test or a BCDR activity, which of the following will offer the best value during the test? Yeah. All right. So let me lock it. I think the correct answer is what has been answered. It is essentially, have a moderator who's well versed in BCDR, to supervise and present. But the more important part there is that you should include randomized special events. So there should be a level of randomness when you do some of these BCDR tests. Again, it's not very special or unique to cloud. In any tabletop test that you do for BCDR, there should be an element of randomness. That would be your real life situation as well. That's why this answer is the right choice. Moving on to the next one.
Anurag, I just want to want you to hold. There is a question in the chat. What happens if the DRBC is with the same provider but in different geolocations?
So you see DR in different geolocations. Yeah, I mean, it's a level of BCDR that what your strategy and what you're trying to achieve with it. In my view, I think it is when you segregate the entire cloud provider itself, you are at the ideal BCDR situation that if the cloud provider itself goes down, let's say there is a core issue within the cloud service provider that kind of puts the entire service provider, in an outage situation, you have a BCDR facility completely independent of it and is available, right? So that is one level of BCDR. If you think that is too costly compared to the cost that you would incur in a BCDR situation, you want to, have you have more risk appetite. You may consider, as what you said, you can then have you can configure your cloud in a way that your production runs or data essentially is hosted at one location, geolocation, and your backup is hosted at another location. So again, it depends on your overall strategy. But ideally, when we look at cloud and you're looking at cloud itself as a source of threat or risk, I think then you would put it and separate it and keep it in a separate cloud provider.
I have a follow-on question for you. This has not been asked in this room here, but it's a typical question which gets asked around in every organization. Anurag, I mean, I'm taking into confidence your experience, the size of the organization you've been engaged in the past and currently working in. And I think there is no right or answer, but just to invoke a discussion here. Traditionally, we always talked about a disaster recovery activity or a BCP and DR drill. But when your complete infrastructure is in the cloud, how easy is it to do a DR drill? Or is it still relevant? Should people be doing it? Just a perception of yours. I mean, there's no right or wrong answer here. It's all about having a conversation, and from a best practice perspective, is it? In real life, it will boil down to dollars and cents.
Yeah, and I don't know what your thoughts are as well. I think in one way to look at it is it may not be as critical as if everything was on-prem, but even if things are on cloud, you still have business processes that are running and using those cloud resources. So the DR is more in terms of you have an office premises from where you connect to your cloud via VPN, and then you access the resources. So it depends on the DR scenario that is being invoked. If your office premises is not there, can people still access things through a remote location in the same way and work in the same fashion? Or if it could also be whether it's the building, it's the equipment, it's the third parties, it could be the people availability, so on and so forth. So what scenarios you're looking at, I think the scenarios would be lesser compared to if everything was on-prem, but you would still have some scenarios for the entire thing to work end to end, and you would test those scenarios in a cloud setup.
Thank you, Anurag. I'll let you continue, guys. If you have any questions, please unmute. Open your cameras, engage. Thank you. Anurag, over to you.
Thank you. Yeah. So we are going back to the question. So your organization has its production environment hosted by a cloud provider, and you have appropriate protections in place. Which of the following is a significant consideration for your BCDR backup? So I'm seeing access to the servers where BCDR backup is stored. So, okay, let me move on. I think the answer here is actually the second one, which is good cryptographic key management. This is probably a difficult one, because at the end of the day, when you are storing the backups at a location, you would need the backup to be available and usable when you try and use them, when you restore, let's say, your data backups that you have in place. And if you're using those and because everything would be encrypted, because encryption would be one of the key control that you would have it put in place, you would put encrypted data in your backups. You would need to have a way to decrypt it years from now, or maybe a period of in future from now. And for that, you would need to have the keys available to be able to decrypt it, and the key in your production may keep rotating. So how do you have that key management process in place so that when the backup is restored, you are able to get the right keys to be able to decrypt and use that backup in your environment? Because the answer that was done, access to the servers where the backup is stored, I don't think you would get access to the servers itself if you're using, if you're just hosting the backup at a cloud location, and if you're using it as a platform or a software as a service, the servers themselves, the physical servers, you would not get access to them because the cloud will not provide you that access due to the multi-tenancy that exists in cloud. All right, so we'll move to the next one. Industry best practices dictate that cloud customers do not do what? Any thoughts on this one? I saw some responses come in. Yeah, I will lock it. I think the response there is correct. So yes, don't create your own identity and access management solutions, because as per best practices, I think custom IAM builds can become weak if not properly implemented. All the other choices there is something that rather you would be encouraged to do, right? You should have that favors you. You should have a contract language that favors the customer. You should retrain your personnel for using the cloud, and you should always encrypt data before it reaches the cloud. So those are all valid choices that you should be doing. What you should not be doing probably is to not create your own identity and access management solutions. Use proven, tested, and industry-wide solutions that are sustainable and can be managed in a better way. All right. It is possible for the cloud customer to transfer what risk to the provider, but the cloud customer always retains ultimate legal risk. Yeah, I think this would be an interesting question. I want to see what people think about this. Right. Interesting. Okay, so I'm going to log the question now. Let's see. So it's the financial risk. Right. So you cannot transfer the data risk. Data is always owned by the risk. I mean, the risk of data is always owned by the customer. You cannot transfer it in any way. What you can transfer is actually the financial risk, because through the contract terms, you are able to put in place SLAs, and you would be able to, recover some monetary damages or even penalties from the provider as a result of a loss suffered by the customer. But the ultimate legal risk or liability lies with the customer. That cloud provider is only a third party serving the customer. So the ultimate legal risk is with the customer, but the financial risk of an outage, let's say the cloud provider does not provide you the services as per the availability SLAs, and you have a business loss. That loss, to some extent, you can recover from the cloud provider if your contracts are in place in such a way that puts penalties and monetary damages onto the cloud. Right? So it's important. One of the things you will see how important the contract and SLAs is in a cloud service provider setup. because that's one of the strongest tools that you have in governing cloud services that you get. Other than the controls that I spoke about, encryption, which is one of the most primary controls. Contracting is another one big aspect of running cloud services. All right, we will move next. So a process for Dash can aid in protecting against data disclosure due to lost devices. Yeah. Okay, so 50-50 split. So let's see. It's actually credential revocation, because device tracking, you will be able to track the device, but you cannot assure that it's protected against data disclosure. You may only be able to see where the device is, but credential, maybe you can track the device, but then post that credential revocation will make the data that is there on the device unusable, because you're not able to encrypt and use the data because you've been able to revoke the credentials. So that's the reason why this is the right answer. So it is best to use variables, and I just spoke about it, but let's see if you were able to recollect this part. So it is best to use variables in what situation? Baseline configuration, security control implementations, contract language, or BCDR tests. Okay, I will give a few seconds more. All right, let me lock it. So that's not the right one. I just spoke about BCDR tests, like tabletop exercise. If you're doing, you use randomness there. That's the variable I'm talking about. You will never have a variable in a baseline configuration. Baseline configuration should always be it should be pretty much locked down. It should always be prescriptive and specific enough to say what should be the configurations that any instance running that technology should adopt from the get-go. Contract language, security control implementation should not have any variables. It's the BCDR test where it's good to have variables because you are testing how people react in an unknown situation. So you would put in an unknown situation that, if the response procedure said you need to call up XYZ person as a step, and that person, and you're just assuming that person is available to take certain activities, you would put a variable there to say, just assume that person is not there. What is your response then? And then you test that individual's or that role's, ability to react with that randomness provided. Things like that. That's what the question is asking about in this situation. Okay, so sprawling in the cloud can lead to significant additional cost to the organization because of what? Yeah, cool. So that's correct. I think the software licensing is the cost that you would incur if you don't have management control on who is, on your usage of cloud in your organization, because it's so easy to use cloud. As I said, again, going back to the thing that I said in the beginning, most of the cloud characteristics are also the reasons why cloud has those unique risks. So self-service, on-demand characteristic of cloud is the reason why you have this risk where sprawling can occur, shadow IT can occur, and that can also lead to financial risk because of you ending up paying software licensing for things that you don't really need. So this is more of a management control you need to put in place, having some governance on top to ensure that only there is a process, or there's a limited, or there's a group of administrators who place a governance process to check what is being used, why it is being used, and who is using it, so that you have a visibility on on the usage. The other closest answer to this could have been larger utility consumption, but utility consumption is not that high of a additional or significant cost that is typically always rolled up into the per instance cost anyway. So it's the software licensing that is really the significant cost element here. I'll move to the second last question here, which is DDoS attacks do not affect what for cloud customers? Great. So that's correct. It's the integrity that is something that is not affected. All other characteristics are impacted by a DDoS attack, which again, I think is common for all, not just cloud specific. So which of the following is a risk in the cloud environment that does not exist or is not as prevalent in the traditional environment? I think this question is will be an interesting one to understand. Okay, so let me clear what the answer is. It's the loss of availability due to DDoS. So the reason being that DDoS always leads to loss of availability, but in the cloud environment, it's much larger because you are not talking about one customer or one tenant impacted. You're talking about all the other customers or tenants who are using the cloud service provider. So the magnitude of the impact is much higher in a cloud setup with a DDoS attack. So that's why if you read the question, it is basically saying which of the following risks is not as prevalent in the cloud, in the traditional environment. So that's where this stands out. Because other one, loss of value, loss of confidentiality, loss of liability is not even applicable in a DDoS so much. It's a loss of availability always with DDoS. And then the magnitude of it is much more in a cloud environment than a traditional setup. All right. I think that covers our domain 3 questions. I will move back to the next section. Just give me a minute. All right, let me start sharing the screen again. Okay. So that gives you a flavor of the infrastructure and platform security within the cloud, which was domain 3 primarily. Domain 4 talks about application security. And I think, again, application security in cloud is not so much of a different domain than how it is traditionally. I mean, this domain talks more about the standard practices that you would need to employ when you're trying to secure cloud application in the cloud. And ultimately, the application security is also in any IT environment would be the most critical layer of security, because if your application is insecure, the entire enterprise ends up being insecure, because that's the gateway to your information, to your data, and then and everything else from there on. So if you look at the standard agenda which gets covered in this slide, or in this domain that you see on this slide, it talks about the training and awareness for application security, how important it is. It introduces you to the secure software development lifecycle process, so nothing very different there. It talks about the standard process of embedding security from every phase of application development. It talks about DevSecOps in an agile environment. It talks about applying cloud software assurance and validation, which is what different types of testing you can do. It introduces to you the gray box, white box, black box testing, which are standard concepts in application security as well. It introduces the concept of verified secure software. So a lot of times people use application or software components, which like open source software. And it basically busts the myth that open source software is always more secure because the code is open source, as there are many people looking at it and testing it, which is something that the ISC by CCSP says that you should not really rely on it. You should still be testing it as much as you would do for any other application component. And then it talks about some very specific cloud application architecture. So it introduces you to the concepts of what are microservices, what is cloud native application, serverless concepts, and so on and so forth. And lastly, it talks about the appropriate identity and access management solutions when you're trying to secure applications. So how do you use identity and access management methods? When you talk about identity and access management, there are different ways in how you can do identity and access management. You might use your own existing on-prem IAM system and federate it with the cloud setup, or you may use a third-party identity as a service cloud provider that does the same thing. So it talks about the different options in which you can enable identity and access management when you're trying to authenticate or use cloud services. Talks about SSO, talks about federation, multi-factor authentication, what it is. So some of the basics, the reason I'm not going into it so much is because there is no unique concept here as much that I would want to stress on than saying that the standard application security concepts apply in this domain as well, right? So that's the bottom line. I don't think there is anything specific that I would want to go in and cover when we talk about cloud application security. One thing, obviously, again, it talks about OWASP. You should, if you're preparing for CCSP, you should go and look at the OWASP top 10. A lot of questions come from that because you should be aware of what are the OWASP top 10 listing, and then what are the ways to prevent it. You should also look at the Cloud Security Alliance Egregious 11. Egregious 11, that's the other listing of risks that is there for using cloud. I think if you cover those two things and have basic understanding of cloud application security concepts, this domain is taken care of. So I would again go to and do some questions rather than going through slides. That will help us keep us on track as well. I will skip these slides. I just said these are, I think one of the things also was a struggle for me, and that's why I want to pause there and talk about is this whole API types and what type of some of these architectural concepts about REST APIs. So what protocols they use, what type of languages they use. If you're not into application development and if you've not done this, maybe these are some of the things you might have to read and understand. So again, this goes into some of the technical nuances of application security from that sense. Like it talks about some of the protocols and language formats that you would use. This comes into the play when they're talking about API security. So they introduce APIs and they talk about how you deal with APIs. APIs is nothing but just another piece of, you should treat it as just another software component. It should follow its own, just the way any software follows the secure software development lifecycle. So in that context, this comes into play as well. All right, there's a lot there. I will skip some of these things and go into the knowledge check again. And I will start this start for all of us to see. Okay. So I hope you are able to still use the same link and the QR code that was there. And if you are able to access back into this questions, we can start answering and discussing these as well. Here is the QR code in case you are still trying to log in, and as well as the link to it, the URL to it. Okay, typically REST interactions do not require what? Yeah, so I think that's the right answer. REST is representational state transfer. It does not require the server to store some temporary data about the client. That's not necessary. These interactions, obviously require server-client interactions, but in this situation, in REST interaction, the client is asking the server through the API for data, which sometimes is as a result of processing. The server processes the request and returns the result. It does not require sessions to be enabled between the client and servers necessarily. So that's the correct answer. And we'll move to the next one. Yeah, so I just talked about it. I added these questions because for me, it was something that I had to go and understand as well. But those of you who have been into custom coding and building these, working on these REST APIs and stuff, it should not be difficult. So yeah, so REST APIs use which verbs? So that's correct. What we have there, it's the STTP verbs. So Roy Fielding, who's the author of the dissertation that created REST, was also the author of HTTP. So it's not a surprise that the command set is the same. All right. What language is used in SOAP application design protocol? Okay, so I think we do have a good developer here who's answering all the right questions. And the correct answer is XML. SOAP necessarily uses XML, and therefore that's the right answer. All right. So WAF, or Web Application Firewalls and Database Activity Monitors, functions at level what and what of the OSI model. So at what level the WAF and the database activity monitoring functions work? All right, so I think, okay, so that's a split, but the right answer is 7 and 7 because the Web Application Firewall is working at the layer 7 because it tries to secure the web applications. It looks at the application layer protocols that is transmitted between the client and the server, and so is database activity monitoring. So database applications are essentially at what layer the database activity monitoring works. So 7 and 7 are the right answer. All other answers are incorrect. All right. So yeah, so this domain also talks about, so if you go through these questions, you would understand the breadth of what this domain covers when you get into it. So that's where I think I picked some of the questions which gives you a flavor of what all it's getting into, because we can't cover everything in 10 minutes. So you saw that it's talking about WAF and database activity model. You'll talk about API gateways, we'll talk about the next generation firewalls, and so on and so forth. So what can tokenization be used for? Oh, interesting. Split here. So again, it is, the right answer is compliance with PCI DSS. Tokenization doesn't necessarily do encryption, right? Tokenization is essentially I mean, in other words, I would say tokenization is not used for encryption. Right? Tokenization is used to comply with PCI DSS, which where as a means to protect the account and can't hold the data at rest. It's not an encryption. There is no encryption engine, no key involved in the process. Therefore, encryption as an answer is incorrect. So merchants who accept credit card payments can avoid some of the compliance burden for the PCI DSS by outsourcing the tokenization function to what? So, well, the answer is straightforward. It's to a third party. When you tokenize, when you use tokenization, you use a third party where you're actually where you actually put the credit card and the token combinations. Okay. All right. I'll move on so that we are able to get on time with the break that we need to get at about 2 o'clock. So which of the following is an example of useful and sufficient data masking of the string CCSP? So when you do this application security, they'll be talking about different ways in which you do data obfuscation. Data masking is discussed as well. Pseudonymization and all those topics get covered as part of how you use data when you're trying to test applications, or how do you ensure you use as close to possible production style data, but you don't disclose sensitive data. So in this example, the correct answer is actually the third one. So data masking, you would actually have, it basically, you would still, in 3x91 example that you chose, you pretty much moved the entire data completely. So there was no remnant of the original string that was CCSP. And therefore, that was not a good example of data masking. It's the third option, which is listed there, TLP. So dynamic testing of software is maybe most useful for what? Dynamic testing is useful for what? Wow, there were a lot of different views here. So should I lock it? Okay, so it's simulating negative test cases. So dynamic testing is typically done to um, uh, allow users to operate it and also look at in usual sense when you're trying to use the application, what are those negative scenarios that you and trying to see how the application reacts to those negative scenarios, what you're trying to test here. So positive testing always happens because you have where you make a lot of assumptions about how the application should behave. If you provide input A, it should give you input B, but all the other variables under which that application performs, you may not be able to fully test unless you do a dynamic testing. So which is basically use of both good and known bad inputs, right? So that is what dynamic testing really tries to achieve. It does not do a source code testing. It's not source code testing, so it does not help in finding errors in the source code. I think all the other, it does not involve any kind of social engineering, so it does not apply in the third option. And penetration testing occurs in the production environment, not on pre-deployment software. So therefore, it's not a correct choice as well. Good. So software development should be perceived as what? I think that's correct. It should be straightforward. It's a life cycle because when you do software development, you test things and you deploy. Testing would lead to some known bugs or improvement areas. You would again go back into the life cycle. You keep going through the cycle of design, build, test, deploy. So it keeps running in a life cycle all the time. Okay, I think there's one last question which I will put up. The inclusion of security controls in the software design process is dictated by which body? Which of these bodies is relevant when it comes to security controls that should be in place in a software design process? So if you don't know the answer, I think you can use the process of exclusion. But I think here the correct answer, let me first call out, is ISO 7034, which is specific to application security guidelines. If you don't know that, NIST 837 is, I think, risk management framework. So you won't really be talking so much about software design. AICPA, it's nothing to do with software design. It's for public accountants. HIPAA is, again, not so much about software design, more on privacy and PHI. So from an exclusion process, you can arrive at ISO 27734. It's also the application security guideline specific ISO guidance. So I think that's how we cover or finish the questions for this domain as well. We would want to take a short break before we continue again. And let's take a short break about 10 minutes so that we can come back by about 2:15, if that's okay with everyone. By 2:15, we will reconvene. I'll just put up a note for that so that anybody logging in is aware of it as well. All right, so I'll see you all in about 10 minutes from now.